I'm going to present to you something I don't think we've ever presented about Mantle before. How it looks in architecture, how all the different pieces come and combine themselves to make something that I think has one of the best product market fits across the industry from a DeFi perspective, but also from a builder's perspective. But let's just start from the beginning, right? Whoops. Oh, this way. Yeah, so I'll talk about architecture evolution over time, like where things are and where we're going. And then I'll go into Mantle, like what are the kind of products that we think really make sense for us and how we've seen ourselves evolve, even though we're slightly over a year old. And then we'll talk about beyond our network, right? And hopefully you'll see like Mantle is not just like a network, which most people think of us as, but it's beyond that. It's a huge ecosystem of good product market fit across the L1, the L2, and beyond. So let's start with a little bit of history, right? So the first paradigm, and kudos to like Eigenlayer for some of this inspiration of these diagrams, and I put them all together from a mental perspective. We started out with monolithic blockchains, and the first one was Bitcoin. It was mostly just for solving a use case, right? The use case of store of value or this idea of solving double spend in a way that doesn't require a centralized actor on a centralized database. You see here a couple of parts, right? So if we don't want a centralized actor, we need crypto economic security consensus. So that big orange blob kind of represents the economic capital and incentives. It could also represent the extent of proof of work, computational power, how much people actually spend to produce those blocks. Over there and just above that, that's kind of like the gray little blocks. That's kind of like the data availability and execution. So think of it like the miners having to then think through state transitions, collecting all these transactions and putting onto the block. And Bitcoin never thought about it, and Satoshi never thought about this. All these primitives are assumed. Data needs to be available before you can have transactions to be processed, right? So, and process, and if they are valid or not, they actually end up in settlement, which is state, right? Alice has 1 Bitcoin, Alice sends 1 Bitcoin to Bob, Alice has 0 Bitcoin, Bob has 1 Bitcoin. And this is how everything started. Subsequently, people thought about it, wait, we can do more than just simple state transitions over values of this asset called Bitcoin. We could do other types of values. So Namecoin is a project that sort of leverages the fundamental same crypto economic security to try to do a little bit called merge mining, kind of like using an enhanced version of the underlying nodes to leverage on that consensus and security, but have a different use case. Like in this case, kind of like domain name services. But challenge is, you're still forever fundamentally limited by the size of those blocks, the computational power of that processor, even though there's a lot of crypto and economic security. So people got frustrated, and then somewhere in 2016, people were like, okay, let's get rid of this, let's just fork the whole thing and create a new use case. Sometimes the use case could be the same, another form of state transitions with sort of a state that's kind of linear, and that state represents the value of the underlying tokens, like in Doge case or Litecoin. But notice that crypto economic security, think about that little blue area or the little yellow area, that's lesser, right? And it actually fractionalizes the security overall as more and more of these forks exist. So there came Ethereum. And with Ethereum proof of stake, we had a new way where you had the same structures for crypto economic security, but on a proof of stake system. But this, and you also have block space and processors, in other words, nodes and validators. But the state is very different now. You have a Turing complete state. What that means is that you basically have applications that could code in Turing complete ways, which means they can code quite literally anything, including creations of new assets. So suddenly, crypto economic security on the base layer supports value on top. So you start to see, hey, there's this 3D structure. So think of the little green one that could be, some abstract version of USDT. The yellow one could be some abstract version of WBTC or FBTC, and so forth. And these are value, right? They look at them in the 3D form. They have value, but their value depends on the crypto economic security and the proof of stake. We had a challenge though. We're still bounded by the speed of the processor and the size of the block space. So the next paradigm was to say, hey, let's do rollups, right? So rollups solve something that initially forks couldn't do, which is we could leverage the underlying crypto economic security, and we could take parts of it as well. So you think of it, that slightly chunkier green part, that's sort of like a way of saying, okay, we will put some of this crypto economic security into an optimistic situation, a challenger situation for optimistic rollups, or it could be used for executing verifications. And think of the gray parts now as a new construct, sequencers, which are, instead of processors, co-processors. So sequencers are now co-processors on a set of block space. So in this paradigm, block space here still sits on Ethereum, and in the old days, well, years ago, well, not too long ago, it was all call data, which was expensive. And we could then roll up transactions which have a whole new set of EVM execution and dApps. So think of the red portion as some dApp that exists on the L2 but doesn't have anything on the L1, right? So we could create new things, but in this structure, we solve the problem of, hey, leveraging the underlying crypto economic security, but also having very, very cheap fees. Because we do a huge batch of these transactions into either a proof that is optimistic or a ZK type proof, a validity proof, and that is just a finite, smaller transaction on Ethereum. So that way we actually solve on the gas fee. We actually realized, wait a minute, coprocessor is only one part of it. Or earlier we talked about data availability. So actually, we don't necessarily need to have that data on Ethereum. So subsequently, like a seminal paper came out from, I believe, the Lazy Ledger Celestia team on the ability to use erasure coding in a different way to be able to keep just the blobs. And in that way, hey, we could just have a reference pointer, just point that back to where the coprocessor is to verify that the data is there. Now, so what that does is that, okay, I have some form of a proof, but where does the data is to validate the proof? Let's put it on Celestia, let's put it on Avail. But once again, as you see in this construct, where's the underlying crypto economic security? It's not on Ethereum, right? As you see in the purple block right there, that's a crypto economic security that's somewhere else. Could be Celestia, could be Avail, could be some other consensus mechanism. How do we get that even better? And that's where we start to say, hey, we could actually use AVS. So that's when you actually see, in this diagram, you see a light blue part that was like POS Ethereum, proof of stake Ethereum, staked ETH. And the dark blue part, that's kind of like restaked ETH. And restaked ETH, whether EigenLayer, Karak, Symbiotic, they have different AVS systems. And then from there, what do you have? Well, you have things like EigenDA, right? So EigenDA could then leverage this restaked ETH in a crypto economically secure way, but in a cheaper way, and then provide this data availability service with erasure coding in a way that, hey, it actually meets the security assumptions that is aligned for staked ETH. Okay, sounds cool, right? So it looks like things are getting more and more colorful, more and more difficult. But where does Mantle come in, right? I just painted you a bunch of architecture changes. Where does Mantle come in? And why does it make sense? So I'll just jump straight into what Mantle is. So Mantle started out as a liquid staking protocol. It's a very simple idea here. We have proof of stake. We have a rate of return of rewards over validators. We take that and abstract it away, and we call it METH. So holding METH is the underlying token representation of staked ETH. Okay, that's good. That's interesting. That's on the L1. Subsequently, restaking came into the position. So we realized, hey, wait, we have all these METH. We could restake that, and we can leverage different protocols, either EigenLayer, Karak, Symbiotic, whatever there comes for restaking. But that's not really enough. Just think of it like DeFi building blocks. That's not enough. We also have a network. So the layer 2 is an optimistic rollup. It combines this rollup with our own data availability solution, which we'll show you later why this whole system works. We have MNT as a native token, so we consider it as gas, and because of that, we have really low fees, high security, fast transaction times, and the trust assumptions on the layer 2 derives from the crypto economic security of Ethereum. And we also have a treasury. So because of all the different activities, we have really accrued a lot of value for the MNT holders. And we have a lot of significant holdings, not just in like native tokens like NMT, but in stablecoins and ETH assets, as much as $1 billion. So valuations hover back and forth, but yeah, that's roughly where we are. And it allows us to leverage these assets to either provide liquidity or cutting-edge development, going into the ecosystems that we think will make sense, and to support developer innovations that totally make sense for the next generation of protocols. So with all this, how does it actually look, right? Let's put it all together into architecture right again. So this is what I say Mantle beyond the network. So I think most people know Mantle as the L2, right? This system of optimistic rollups. Sure, that's fun, that's good. That's everything that we stand for to enable an ecosystem of developers. But it's beyond that, as we can see here. So we have the MEF protocol. So the MEF protocol can sit both on the L1 and L2. So it abstracts away the proof of stake. And it goes right down back to contributing stake into Ethereum. We also have Mantle Treasury. So Mantle Treasury has a lot of assets activated down into MEF protocol, down into CMEF, which will be our restaking liquid staking derivative. And for that, we activate that to enable next generation of restaking protocols, so like AVS, like EigenDA. And then we take things like EigenDA and we use it as data availability in Mantle Network. So you can think of us as both a producer and consumer of block space. And in that way, this makes this entire ecosystem circular, and it creates an economy for developers. And on top of that, of course, there's active ways to continue these innovations, be it not just for Mantle, but to enable these assets and its growth through shared sequencing and chain abstraction. So what does this really mean when you put this all together in this circular diagram and economy? Well, it means that Mantle has a thriving ecosystem where you have quality U assets who are necessary for crypto economic security, sustainable capital deployed into these things that have quality yield, near zero fees for developers, at trust minimized assumptions, right? Think of the L1, the L2, everything relies on the same fundamental crypto economic assumptions. And because of that, it creates this sort of like crypto economic fertile soil for developer growth. As a person who been in playing roles in DevRel and many roles in improving developer ecosystems, one thing that I realized for developers is not just the ease of programming. I think we have that with EVM, but it's the conviction for developers that this is the ecosystem that they can grow. right? So with quality assets, good product market fit, sustainable capital, and sustainable yields for crypto economic security with the same assumptions throughout the L1, L2, and beyond, that just creates a completely strong value proposition that any developer should be part of this ecosystem. In 2049, right, a lot of times we come here for token 2049. What will Mantle be? I don't think you will see these charts anymore in 2049. What you will see is an abstraction where people understand all these value propositions into a brand, where Mantle is not just a network, Mantle is not just a protocol, but Mantle is an enabler for sustainable developer growth. And yeah, with that, that's all my time. Thank you.